What I was saying in the previous video is applying the formula which says that fr vector is equal to its fx x component I vector plus fyj vector. So we just do the substitutions, and in order to find the magnitude, we have to apply the formula radical of x squared plus fy squared, and we get the following results: 11.52 Newton. But however, when you're asked to calculate the resultant force, it's not enough to find its magnitude. You have to find the angle between this resultant force vector and x-axis in order to be able to determine, or sorry, to represent this resultant force. So in order to calculate the angle theta between fr vector and x-axis, we can either calculate the cosine of this angle or its sine or even its tangent. So I chose one of them, and I said that cosine theta is frx over fr, as we discussed before, or you can use sine theta equal fry over fr, or even tangent theta is equal fry over frx. So we have that theta is the inverse of the cosine. You press on shift cosine on your calculator and put the ratio of frx over fr within parentheses, and the angle here is 20.64 degrees. So now if I want to represent this resultant force vector, it is as follows. Its vertical component is 4.07. So by taking a convenient scale, I have to represent here 4.07, and its x component is 10.78. So this is it horizontally. Why did I draw it in the negative direction? Because we already knew that in the previous calculation. So please make sure and pay attention to this thing. So it was wrong to draw it in the positive direction. And the force vector, the resultant one, is thus it's actually the diagonal of the palm formed by, or it's the diagonal of the rectangle formed by these two components. It is here represented in yellow, and as you can see, I showed that the angle uh, between the x-axis and this is 20.64, and its length is 11.52 in Newton.